This video is going to walk us through quadratic applications, specifically projectile motion. So projectile motion is going to be if I throw something, kick something, launch something out of a cannon. What happens if you throw something into the air is gravity is going to pull it back down, and that creates a quadratic function. It creates a parabola. So we're going to look at different projectile motion questions today and then answer things about that function. So we have two different scenarios that it could occur. One, it starts from the ground, which would be this image on the left. So that would be if you're kicking a football or a soccer ball starting from the ground, it goes up into the sky and then it hits the ground again. Starting at a specific height would be if I kicked a soccer ball off of the roof of the school, then now your y-intercept is going to be your initial height. Okay, so the initial height in any of these problems is going to always be wherever your y-intercept is. Then whatever the item is, let's say it's a soccer ball, it goes up, it reaches its maximum height at the vertex, and then it comes back down and it hits the ground or the water or the floor or the dirt, whatever it's talking about. The ground is going to be the x-axis, so whatever your x-intercept is. The reason it's that is because when you're doing these problems, so we're going to utilize Desmos today to help us, and we're going to be able to see a lot of different coordinates on the graph. So when you're doing these problems, it's important that you can analyze a coordinate, okay? So for the word problem, and it shows that in these images as well, but for projectile motion word problems, the x value is always going to represent time, and the y value is going to represent the height. So if I gave you a point 3, 0, that means that the height is 0, which is the ground. So the x-intercept is always going to be the time that it takes to reach the ground. Okay, so let's look at some examples. And I would open up Desmos and have Desmos running simultaneously to this video, the graphing calculator to be specific, because we're going to use Desmos to find all of these answers. So on this slide, I've already graphed the function that is that's given to me here in Desmos, and this is the result. Now, when you graph that function in Desmos, it's going to look different to you because your scale might be off. So notice my scale here is going by 50s, but my scale down here is going by 2s. You can manipulate the scale to make the graph easier to look at. You can also just zoom in, zoom out, up and down, and you would still be able to find all of these answers. So Chris hit a golf ball into the air from the ground, which can be represented by this function. The graph represents the height of the golf ball in feet as a function of time in seconds. Use the graph to answer the questions below. All right, so we've got, this is where we're starting at, okay? So the ball is going into the air, it's coming back down, and then this is where it hits the ground again. So for question A, how many seconds will it take the ball to reach the ground? You can click on the x-intercept and it will show you a point. So that's at 6 seconds, the height will be 0, which is the ground. You can also utilize the table in the event that it's not a decimal x-intercept. But the reality is when you're doing a projectile motion problem, if Chris hits a golf ball in the air, it's not going to hit the ground at a perfect amount of time. So a lot of times you will get a decimal, which is totally fine, and you would just write that decimal as the answer. So for this question, it hit nicely. How many seconds until it hits the ground? It would be 6 seconds. Make sure you're including your units. These problems are all going to be in feet and seconds. What is the maximum height of the golf ball? So this would be the max height here. Now this one is going to be a little bit trickier because the max height, and in the table it shows it also. It's going to give you a coordinate. So 3, 180. It's important that you know what the 3 represents and you know what the 180 represents. And then that you know what the question is asking you for. So it wants to know what is the maximum height. So we're looking for the height, which is the y coordinate. So the maximum height would be 180 feet. Determine the height of the ball after 1 second. That would be utilizing the table. So you can go to the table, you can make the table go bigger, but after 1 second, the height is 100 feet. It's going to definitely be easier for you to see answers like that in the table versus trying to zoom in on the graph, especially if your scale is going by a bigger number. All right, so what is the domain of the function? Domain is x. So some of you might be tempted to write negative infinity to positive infinity because that's what the domain is normally with a quadratic function. But the domain, you would be saying domain is x, which is time. So if you say negative infinity to positive infinity, you would be saying that the ball was in the air from negative infinite time and then it just stayed in the air forever. But that doesn't make any sense. So the least amount of time that this ball was in the air was 0 seconds. And for your word problems, that's where we're going to start. Time is at 0, then where is it at half a second later, 2 seconds later, 8 seconds later? When does the time stop? That's going to be when the ball hits the ground. So the ball hit the ground at 6 seconds. So the domain, even though on Desmos the graph keeps going, the domain in terms of the x-axis, it started at 0 and the graph stopped at 6. So then for the range of the function, now the range is the y values, so I'm looking at the height, okay? What is the lowest height to what is the highest height? You're basically looking at minimum to maximum. And again, this is a word problem, so we're not looking at, Desmos is helping us to find some of these answers, but we're not looking at the whole graph. If Chris is hitting the golf ball in the air and then it's hitting the ground, everything is living in this first quadrant. So the lowest height that the golf ball ever was would be 0 feet in the air. So 0. And then the highest that the golf ball got to was 180. So the range would be 0 up to 180. Determine the height of the golf ball after 4 seconds. That would be, again, utilizing the table and understanding that x is time and that the y value is the actual height. So after 4 seconds, the height would be 160 feet. Determine the average rate of change in the height of the golf ball when the time increases from 0 to 2 seconds. So what is this rate of change between 0 seconds and 2 seconds? So table is probably the easiest place to look. And then we just need to make sure that we know our formula for average rate of change, and it's the same formula as the slope formula. So y2 minus y1 divided by x2 minus x1. And the order doesn't matter, so we could do 160 minus 0 over 2 minus 0. So making sure that we stay consistent. If y2 is 160, then x2 needs to be 2. So this would simplify to just 160 over 2. Which equals 80. So the average rate of change in the height, it changed 80 feet per second over the interval of 0 to 2 seconds. Example 2, Wile E. Coyote is bound and determined to catch the Roadrunner. He's standing on top of a 90-foot cliff and launches himself on a rocket upward at an initial velocity of 112 feet per second. His height after t seconds can be modeled by this function. So again, I would make sure to have the graphing calculator open. I would try at this point in time to see if you can plug this function in to Desmos and get the same graph. There are two different ways to type a function into the graphing calculator. So if you don't put f of x or you don't put y equals, then the automatic default is that the input variable is x. So you have to put x in as your variable, or you will not see a graph there. It will show you a little slider and make you define what your input is. If you use function notation, so if you type in h of t equals, then you're defining the input variable to be t. And so then when you type it in, you can use negative 16t squared plus 112t plus 90. So if you're going to if you would like to use the variable t, you can type this in exactly how you see it. Just make sure that you include the output, which is h of t. All right, so how many seconds will it take Wile E. Coyote to hit the ground? So we know that this is our x-intercept. We have two x-intercepts on this problem, but this x-intercept over here doesn't make any sense. One, because it's negative. Two, because it doesn't have to do with Wile E. Coyote launching himself. We are living in the first quadrant. So he launches himself right here off of a 90-foot cliff, goes up and reaches the maximum, and then comes back down and hits the ground when the height is 0, which is 7.728 seconds. We are not going to round this any further than it's already rounded. Desmos is rounding to the nearest thousandths place, so we're gonna leave this decimal as accurate as possible. The more that you round it, the less accurate that value is. So we would want to write the full decimal. Decide how many seconds it will take Wile E. Coyote to reach its maximum height. So the maximum height is at the vertex. It's important to remember that the x coordinate is the time, and the output or the y coordinate is going to represent the height. So be careful with this question and that you're reading it correctly. It says how many seconds will it take him to reach the maximum height? So that would be 3.5 seconds. Part C, what is Wile E. Coyote's height after 7 seconds? So that's utilizing the table. You can keep the table going, or you can just type in 7 right after the 2. And that will give me the height. So the height is 90 feet. Calculate the maximum height of the rocket. So now we're back at our vertex. The maximum height is the highest point. Time was 3.5, so 286, my y coordinate or my output, that is my height. So the highest that he got was 286 feet. So what is the domain of the function? Domain represents the x value. So that's going to be the time that Wile E. Coyote was in the air. So the time is always going to start at 0, and it's going to stop whenever he reaches the ground. So this would be from 0. And it's important that you use a bracket and not parentheses. If you use parentheses, you would say that we are approaching 7.728 seconds, but we actually hit the ground at that point. So that's part of my domain. And then for the range, it is the height. So what is the lowest height up to the highest height? So on this one, it might be tempting to start with 90. He started at 90, and then he hit the ground, so that would be 0. But for range, it's always low to high. So even though he was at 90 feet at one point, that's not the lowest that he was, and that's not the highest that he was. The lowest height that he was at 0 feet when he was on the ground, and the highest that he ever got was up to the vertex, which was 286 feet. What is the average rate of change from 1 to 3 seconds? So at 1 second, he was 186 feet in the air, and at 3 seconds, 282 feet in the air. So we would do y2 minus y1, so 282 minus 186, all divided by 3 minus 1. And you can type this whole thing into the calculator if you want. 282 minus 186 is 96. 3 minus 1 is 2. So that would give me an average rate of change between 1 and 3 seconds of 48 feet per second.